Hello everyone. The topic of our project is machine learning approach for plant disease detection. As you know, the agriculture sector needs a huge upgradation in order to survive the changing conditions of Indian economy. For optimum yield, the crop should be healthy. Therefore, some technical method is needed for periodic monitoring of crop. Crop disease is one of the major factors which indirectly influence the significant reduction of both quality and quantity of agriculture products. Plant diseases are generally caused by pests, insects, pathogens, and decrease the productivity to large scale if not controlled within time. So, there is a need of an automatic, accurate, and less expensive machine learning project which will detect the disease from the image and suggest a proper pesticide as a solution. Here are few examples of the infected leaves. We had considered in total 7 papers in which they had used different algorithms of machine learning and some algorithms of image processing also. In first paper, they had used random forest algorithm which gave an accuracy of 70.14%. In second paper, which we are going to implement, have used the CNN algorithm giving accuracy of 95.08%. Next is the SVM, which is support vector machine algorithm, which didn't give an accuracy at all. It was just a brief study of that project. Next is the paper which they had used image processing using algorithm segmentation feature extraction. Next paper they had used Kenny's edge detection algorithm giving an accuracy of 79.2%. The experimental results indicate that both the approaches can support detection and classification of the disease on the leaf. The level of accuracy in classification of the leaves by multi-class SVM was 83.6%, whereas it was 93.8 when the leaves were classified using CNN. Hence, we are going through the CNN algorithm. Next comes the problem statement. In recent times, server-based and mobile-based approach for disease identification has been employed for disease identification. Several factors of the technology is being high-resolution camera, high performance processing and extensive built-in accessories are added advantages resulting in automatic disease recognition. In order to detect a plant disease at very initial stage, the use of automatic disease detection technique is advantageous. Modern approaches such as machine learning and deep learning algorithm has been employed to increase the recognition rate and the accuracy of the results. This is how the model of our project will be working. First, we will load the data set which is stored into raw directory, that is plant village. Next will be a data pre-processing step in which we will convert each image of data set into array of matrix by using Python's inbuilt library CV2, and then these array are again converted into binary level through inbuilt library which is label binarizer. Next comes the convolutional network steps in which it has 4 main steps. First is the convolution layer. It is the first layer to extract features from an input image. It is a mathematical operation that takes two inputs such as image matrix and a filter or kernel. So this is how it will look. Next is the ReLU layer, which is which stands for rectified linear unit for a non-linear operation. This is important to introduce non-linearity in a convolution network, since the real-world data will want our convolution network to learn out non-negative. Next comes the pooling layer, in which each section would reduce the amount of parameters with the images are too large. Spatial pooling, also called as sum sampling or down sampling, which will reduce the dimensionality of each map. And the last layer is fully connected layer, which converts all the data collected into a simplified version. The above diagram features map matrix which will be converted as vector x1, x2, x3. With fully connected layers, we combine these factors together. Our project was implemented in Anaconda under the Spider library, which we had to install NumPy library, sklearn library, Keras, and Matplotlib library. So this is how, after writing the program, the images which we were using as data set will be converted into matrix. The graph produced will be as shown like this, and the accuracy is 96.77%. Conclusion. I would like to conclude that this application will serve as an aid to farmers regardless of the level of experience, enabling fast and efficient recognition of plant disease and facilitating the decision-making process when it comes to use of chemical pesticides. By extending this research, the author hopes to achieve a valuable impact on sustainable development, developing a complete system consisting of server-side components containing a trained model on application for smart mobile devices with features such as displaying recognized disease in fruits, vegetables, other plants, etc. Thank you.